So there's three things we're going to do in this video. The first thing is I want to emphasize what our emphasis of the week is. It's about being grateful, learning to be grateful for the things that God has blessed you with. The thought of the day, or the thought I want us to think about, is that all that you are or will ever be is by God's grace and should be for His glory. So everything that I have and everything that I can do, it's because God is working in me to do it. And I want to make sure that we remember that. It's all for His glory, and I don't want to take credit for that. Number two, we're doing a problem that involves graphing. And if we're going to graph a linear inequality, there's a way that we have to go about it. And even if you've never done one of these, I want you to pay attention, and it should make sense. And the third thing I'll do is to explain your assignment from Lesson Practice E. So let's go on to the second thing. When you're given a linear inequality, let's pick y is greater than or equal to 2x minus 1. Y is greater than or equal to 2x minus 1. This is going to involve shading a certain region. After you draw the graph, you're going to have to shade where it's true for that expression, okay? Or for that inequality. The first thing is, if you've never graphed before, this should be helpful, okay? You want to draw a table of values. You have your x. I left this blank and I'll explain what I'm going to do with it. And then you have your y. Right here, all you're going to have is you're going to treat this as though it's an equal to sign, and you're going to solve for the values of y, placing certain values of x. What does that mean? I'll explain. What I want you to do is to go from minus 3 all the way to positive 3 for the x's. So whenever you're trying to graph a an equation, you set up your x's from a certain number to another number. You're going to learn about domain and range, and that will explain more detail about what the x's represent and what the y's represent. So we're going from minus 3 all the way to 3. Wherever we see x, we'll place a number like minus 3 here for x. So right here is essentially y is equal to 2 into minus 3 minus 1. 2 times minus 3 is minus 6. So minus 6 minus 1 is simply minus 7. So when x is minus 3, y is minus 7. We move on to the next number. Y is equal to 2 into minus 2 minus 1. So that's 2 times minus 2, which is minus 4, minus 1, and that's minus 5. When x is minus 2, y is minus 5. The third thing I want to point out here is that it continues in that order. And there's nothing else that is different from what we've done. So using that pattern, I want to encourage you to do that all the way to the end. And as you solve that, that's going to give you minus 3, minus 1, and then you get a positive 3. Well, you get a 1, you get a 3, and you get a 5. You notice that if you plug in a 3, you will get 2 times 3, which is 6. 6 minus 1, which is 5. So when x is 3, y is 5. That's how I got these values for y. Now I have my values for x, and I have my values for y. The next step is to actually go to a graph and draw those points, and then I can draw a line. Okay, so we go to minus 3 right here, and we trace it down to minus 7. So that's our first point. The next point we have is minus 2 minus 5. So we go right there. And then the next point we have is minus 1 minus 3. And then we go to 0 minus 1. And by the way, you should know that you're going to get minus 1 as a point, and it should be 0 at that point, because the y-intercept, when you have y is equal to mx plus b, the y-intercept is the b. And in this case, the b is minus 1. So you should know that. You have 1, 2, 3, 4 points. The next point we have 1 and 1. We have 3. So when x is 2, it goes in there, and we have 4 minus 1, which is 3. So when x is 2, y is 3. And then our last point here is 3 and 5. So when it's 3, we get 5 right there. And so we draw a line. Now the question is, are we going to shade this part, or are we going to shade that part? One of the things that the other textbook does is that they just place it with zeros. So 0 right there, for example, when x is 0. So y is greater than or equal to 2 into 0 minus 1. So y is greater than or equal to minus 1. If you place a 0 for the y, so we're using 0, 0 as our test point. If you place a 0 for the y, you get y is greater than or equal to minus 1. Is that true? Is y greater than or equal to -1? What part will be shaded at this point? With this graph, we'll shade that part. That's what makes it true. And so when you shade it, you're done with the problem. And that's the second thing I want you to know. The third thing we're going to do quickly is we're going to look at lesson practice E. It tells us that Trevor has two appliances connected to a power supply that provides 15 joules of power per second. If X represents the power of the first appliance and Y represents the power of the second appliance, the question is basically asking us, one, to set it up and then to draw a graph. It says we have two appliances and then we're meant to graph the region that shows the possible power to each appliance. Use your graph to determine whether Trevor can send 7 joules per second to the first appliance and 6 joules per second to the second appliance. The way you set it up is X plus Y is less than or equal to 15. Y is less than or equal to 15 minus X. Y is less than or equal to minus X plus 15. Take those values, draw your table of values, draw your graph. You will have things in the positive region. You mostly have things in the positive region right there. And then you can answer the questions that they ask. If you have any questions about that one, we can talk about it later today. So that's all for this video.